In a survival situation, fire provides life, but one mistake can turn your world into a biological nightmare. Imagine a survivor reaching for a hot pot over a campfire without any hand protection. A momentary lapse in judgment occurs, leading to a searing flash of immediate, shocking danger. The instant pain is a primal warning sent from the microscopic layers of the skin. Your body's defense systems instantly begin their desperate fight for survival against the thermal assault. The intense thermal energy from the scorching pot immediately assaults your skin's outermost protective layers. This sudden influx of extreme heat profoundly disrupts the delicate cellular balance within your tissue. Microscopic proteins inside your skin cells start vibrating violently as they absorb this destructive energy. Your body's complex defense mechanisms are instantly overwhelmed by this powerful and destructive external force. The penetrating heat affects the living cells beneath the surface, triggering a cascade of damaging events. The extreme temperature causes your skin's vital proteins to rapidly lose their natural functional shape. Think of these proteins as tiny, folded workers who suddenly lose their structural integrity. When exposed to intense heat, they unfold and become tangled, completely losing their ability to work. This irreversible change is called protein denaturation, a fundamental chemical breakdown process. It is much like watching a clear egg white transform into an opaque and solid white. The heat breaks the delicate bonds holding the proteins together, permanently altering their very nature. This chemical alteration directly causes the visible changes as the epidermis begins to break down. Many people mistakenly believe their skin actually boils during a burn, but this is rarely true. The temperature for true boiling is much higher than what occurs during initial brief contact. Instead, the intense heat causes water inside your cells to rapidly vaporize into steam. These trapped gases and steam expand dramatically just beneath the surface of the skin. This expansion creates immense internal pressure, giving the powerful illusion of boiling tissue. Microscopic explosions occur as individual cells, unable to withstand the expanding steam, rupture violently. Their delicate membranes burst, releasing contents and contributing to the visible damage. At the very beginning of a first-degree burn, the initial damage is primarily superficial. The injury is only affecting the epidermis, which is your skin's outermost protective layer. The skin appears red because blood vessels near the surface suddenly dilate to increase blood flow. This increased circulation is your body's immediate attempt to cool the tissue and begin healing. Despite the redness and discomfort, the skin's structure largely remains intact during this initial phase. There are no blisters forming yet, so the protective barrier is still mostly functional. The process of protein denaturation is the hidden chemical reaction that begins the transformation of your skin. This cellular transformation leads directly to the physical lifting of the skin known as the Dermal-Epidermal Junction. Imagine a detailed sketchy cross-section of your skin, showing the thin outer epidermis resting upon the thicker dermis. These two crucial layers are normally held together by a sophisticated biological glue made of intricate proteins. This network of cellular structures forms a strong, resilient bond that protects your inner body from the outside world. Extreme heat, however, begins to dismantle this delicate arrangement, causing catastrophic damage to the sensitive cellular structures. This intense thermal energy effectively melts the cellular adhesive, weakening the vital connections between the epidermis and dermis. As this biological glue dissolves completely, the primary layers of your skin finally begin their structural separation. They slowly drift apart from each other, creating a noticeable and incredibly painful gap. The physical sensation of this second-degree burn feels like a deep, throbbing ache combined with a persistent, intense stinging. You might also experience a profound tenderness as the protective outer layer starts its painful detachment from sensitive tissues. Following this initial separation, your body immediately initiates an impressive emergency response to protect the newly exposed tissues. It begins pumping clear plasma fluid, which is rich in vital proteins and antibodies, into the newly created gap. This deliberate influx of fluid causes the familiar bubble or blister to form on the surface of your damaged skin. This blister acts as a remarkable protective cushion, a natural barrier specifically designed by your body to shield raw nerves. The fluid inside this blister is actually a completely sterile environment, carefully maintained by your immune system to prevent infection. This pristine, fluid-filled space is also intended to facilitate the crucial growth of new, healthy skin cells. It provides an ideal healing chamber, promoting the complex regeneration that is essential for a full and rapid recovery. Now, let us narrate the intricate biology of pain experienced during a second-degree burn, which is quite fascinating. The exposed nerve endings are now stripped of their protective epidermal covering, reacting dramatically to air and surrounding pressure. This direct exposure triggers an immediate and overwhelming cascade of powerful pain signals throughout your entire nervous system. Second-degree burns are often considerably more painful than even third-degree burns. a fact that might seem very counterintuitive. This heightened pain exists because the nerves are still alive and functional, actively sending distress messages to your brain. In stark contrast, third-degree burns often destroy these nerve endings completely, leading to a disturbing and dangerous numbness. Sketchy diagrams would clearly show these pain signals traveling rapidly from the burn site directly to the survivor's brain. The brain then interprets these urgent signals as an intense, unavoidable pain, demanding immediate attention and care. Understanding the critical role of the blister is paramount, as it acts as a biological band-aid providing natural protection. This vital covering should never be removed prematurely, especially when you are in a remote wilderness setting. It creates a perfect moist, sterile environment, which is absolutely essential for optimal cell regeneration and faster healing. Therefore, this protective blister should never be popped, because this exposes the delicate underlying skin to dangerous bacteria. This greatly increases the chances of a serious infection and slows down the entire healing process considerably. Leaving the blister intact allows your body to heal naturally underneath its protective dome, minimizing complications. It also helps to prevent excessive scarring while promoting a much faster and more complete recovery from the injury. Understanding the protection of the blister allows us to see how the body handles even more extreme heat. Extreme heat leads us into the third degree, where the body can no longer create these protective bubbles. Imagine a burn gauge shifting from a blistering second-degree injury to a deeply charred third-degree burn. This severe stage penetrates all skin layers, often reaching the underlying fat and muscle tissue below. Surprisingly, the complete absence of pain is not a positive sign indicating your body's miraculous recovery. Instead, it tragically signifies total nerve destruction within the intensely affected and damaged area of skin. These destroyed nerve endings might never fully heal, resulting in a permanent and unnerving lack of sensation. The skin often appears very stiff and waxy white, sometimes turning leathery or even completely charred black. This profound thermal damage shows that the destruction of deep tissue has now unfortunately become quite permanent. This level of injury demands complex medical intervention for any chance of a meaningful recovery process. Severe burns almost always require skin grafts to close the wound, finally beginning the long healing journey. Now, let's debunk some common survival myths that could worsen a serious burn injury quite significantly. Picture someone trying to apply butter or grease onto a fresh burn, which is a misguided remedy. This seemingly harmless act is actually incredibly dangerous because it traps heat inside the damaged skin. Grease forms an insulating layer over the wound, preventing heat from dissipating and cooking tissue further. This harmful practice increases the burn's depth and severity, causing much more extensive cellular damage. Furthermore, bacteria found in butter can introduce a serious infection directly into the very open wound. The correct and crucial technique is immediately using cool, gently running water for at least 20 minutes. This vital step stops the progression of heat, providing pain relief and preventing further tissue destruction. Another perilous misconception involves applying ice directly to a burn, which inflicts severe secondary damage. Extreme cold causes your blood vessels to constrict dramatically, which reduces vital blood flow to the area. This leads to additional tissue injury, often called frostburn, where cells may shatter from temperature shock. Applying ice compounds the initial injury, creating a cold-related trauma instead of helping your body recover. Instead, after thoroughly cooling the burn with water, you should then loosely wrap the entire wound. Use sterile materials from a first aid kit, like a clean, non-adhesive dressing or special cling film. Remember to avoid wrapping the burn too tightly, allowing ample space for any potential and painful swelling. This also ensures you maintain essential air circulation around the injured area to help it properly heal. Understanding the biology of burns and mastering first aid are absolutely paramount for your long-term survival. Respecting fire and acknowledging its immense destructive power is crucial in any outdoor or emergency situation. Always pay close attention to the important biological signals your body sends you during an emergency. These signals are indispensable indicators telling you about the severity of your current and developing injury. Knowing how to react correctly can prevent minor incidents from becoming life-threatening and tragic catastrophes. Proper preparation and acquired knowledge will empower you to manage inherent risks effectively and very safely. Picture a survivor who now carefully manages their campfire, using a long stick from a safe distance. They are wearing heavy protective gloves, clearly showing their newfound respect for the element of fire. Keep your skin intact and your fire controlled so you can stay sketchy and stay alive out there.